In this video, let's talk about trace of matrix. So we have A equals Aij, which is a square matrix of order n. Then sum of the elements lying along the principal diagonal is called the trace of A. Okay, so it is denoted by TR of A. So this is called trace of A. So this is read as trace of A. Let's see some example. Let's see one example to make it more clear. So we have A as 1, 2, 5, 2, minus 3, 1, minus 1, 6 and 5. So the trace of matrix will be sum of elements lying along the principal diagonal. So 1, minus 3 and 5. So this is the elements lying along the principal diagonal. So trace of A will be 1 plus of minus 3 plus of 5. So this will be 1 minus 3 is minus 2 plus 5, or this will be equals to 3. So trace of a matrix is a really important property. We will solve many problems in future related to this topic. So it's a very simple concept. Trace of A is equals sum of elements lying along the principal diagonal. Okay, so you can write it as trace of A equals summation I is equals 1 to n, where n is the order, and summation of AII, where AII represents elements which lie along the principal diagonals. Okay, let's see some of the properties of trace of A. If A and B are two matrices and lambda is any scalar, then trace of lambda A will be equals to lambda of trace of A. It's very simple. Trace of matrix A plus B will be equals to trace of A plus trace of B. Trace of AB will be equals to trace of BA. This is true if and only if both AB and BA exists. So if both the matrices exist, then trace of AB will be equals to trace of BA. That's it for this lecture. I am keeping it short because in the next lecture we will talk about transpose of matrix. If you like my video and want me to continue more, then like this video and share it with your friends. If you are hearing me for the first time, then hit the subscribe button to get the latest updates.